Today we are going to learn about the study of group 1 and group 2, certain properties and certain compound, how it has been prepared. Okay, so group 1, first of all, atomic and ionic radii. Among the period, the group 1 element is having largest atomic and ionic radii. Okay, and group 2 also have largest atomic and ionic radii, but comparatively lesser than group 1. Okay, the reason for that is group 1, when we move from group 1 to group 2, atomic radii decreases because of increase in nuclear charge due to the addition of one more electron in the same shell. Now, when we move down the group in group 1, the atomic and ionic radii increases. Okay, atomic and ionic radii increases. This is due to the increase in number of shell. And as the number of shell increases, the increase in number of shell overweighs the decrease caused due to the increase in nuclear charge. Therefore, effective nuclear charge comparatively decreases and therefore atomic and ionic radii increases down the group. The same case happens in group 2 also. Atomic and ionic radii increases down the group. The same reason. Now coming to ionization energy, the group 1 elements have the lowest ionization energy in the period. Why it is having lowest ionization energy? The reason is because of greater atomic and ionic radii as well as lesser nuclear charge. And down the group we can see that ionization energy decreases down the group. That is because of increase in atomic radii and therefore effective nuclear charge comparatively decreases and therefore there is ionization energy decreasing. Second ionization energy is large. The reason is the second electron has to be removed from the noble gas configuration. We know that the outer electronic configuration is NS1. After the removal of one electron, then it acquires stable noble gas configuration. Nearest noble gas configuration it will be having. So from the stable configuration you have to remove the second electron. So therefore second ionization energy is large for group 1 elements. Group 2 elements, it is also having greater ionization energy than the group 1 elements. The reason for that is nuclear charge is increasing. Therefore, an atomic radii is decreasing. So, ionization energy comparatively will be greater than group 1. Down the group it decreases. Again, therefore, the reason is number of shell increases and ionization energy decreases. But second ionization energy for group 2 is comparatively low. The reason is second electron has to be removed from NS. After the removal of one, second electron has also to be removed from NS, and after the removal of 2 it acquires the stable noble gas configuration. So removal of second electron needs very less energy. Therefore second ionization energy is comparatively lower than what we see in group 1 elements. Now coming to electronegativity. Electronegativity is lowest for group 1. Okay, again here the reason is the atomic radii is high and nuclear charge comparatively is low. Okay, and down the group electronegativity still decreases. Again atomic radii is increasing and nuclear charge comparatively is less. Here group 2 greater is the electronegativity compared to group 1, but it decreases down the group because of increase in atomic radii. Okay, and comparatively nuclear charge, effective nuclear charge is less. Now next, electropositive character. Electropositive character means tendency to give electron. So group 1 elements have highest electropositive character or metallic character because it can lose electron very easily. And down the group metallic character increases. Okay, so it increases down the group. Down the group it increases. And group 2 elements, they have high metallic character. Okay, the reason again they have the great atomic radii and low ionization energy. Okay, and down the group ionization energy decreases, so metallic character will be increasing down the group. Now the next is oxidation state. Since the electron present in the outer orbit is 1, it can lose 1 electron and show +1 oxidation state. And in group 2, Ns2 is the outer electronic configuration. It can lose 2 electron and form +2 oxidation state. Now next one is preparation of compounds of group 1. In your syllabus, you have to learn certain compounds. Among that, the more important ones I have written here. Sodium carbonate, how it has been prepared using Solvay's process. For that, we have to take brine solution, concentrated brine solution is taken, and it is passed through ammonia and carbon dioxide. Ammonia, carbon dioxide in its solution first forms ammonium carbonate. It forms ammonium carbonate. Ammonium carbonate reacts with brine solution. So ammonium carbonate reacts with brine. Brine means sodium chloride, and it undergoes reaction forming sodium carbonate, ammonium chloride. Sodium carbonate is a soluble substance. Again, carbon dioxide, water which is carbon dioxide passed through the solution forms sodium bicarbonate, which is sparingly soluble. So it precipitates out. You filter and take it out. Sodium bicarbonate is strongly heated, ignited to get sodium carbonate, water and carbon dioxide. This is how we prepare sodium carbonate by Solvay's process. So this is the principle involved in the preparation. Now another compound of group 1 is sodium thiosulfate. Crystals have 5H2O in it. It is also known as hypo. Its solution is known as hypo solution. Okay, so remember this term. Sodium thiosulfate is prepared by taking sodium sulfide solution, passing sulfur through it. Okay, sulfur when reacts with sodium thiosulfide at high temperature 373 Kelvin. So boiling sulfur and sodium sulfide reacts to form sodium thiosulfate. So this is how sodium thiosulfate is prepared. Sodium thiosulfate has important properties like it can react with halogen, mainly it reacts with iodine to form sodium iodide and sodium tetrathionate, S4O6, tetrathionate. Okay, so this reaction is used in iodometric titration. It has an application. It is used in iodometric titration. Sodium thiosulfate also reacts with silver nitrate, and it forms silver thiosulfate and sodium nitrate. See, silver thiosulfate is white precipitate, but on exposure, if you are going to place it for some time, sodium thiosulfate will be decomposing in its solution to give silver thiosulfate will be decomposing in its solution to give silver sulfide plus H2SO4. Silver sulfide is a black colored substance. So you can see here in this reaction the color change. White substance, white precipitate turns to yellow, brown and finally black due to the formation of silver sulfide. This reaction is important. Okay. So that is how the color change is happening. Now let's see the compounds of group 2. Calcium carbonate, how it is, calcium oxide, how it is prepared. Calcium carbonate is taken and heated strongly. It decomposes to give calcium oxide. You must have learned in lower class also. Calcium oxide can be used for the preparation of slake lime. This is called quicklime. This is called slake lime. When it is treated with dissolved in water, it forms calcium hydroxide. This dissolution in water gives off lot of heat energy. So you can see here hissing sound produced, and this process is called slaking of lime. Lot of heat energy is evolved and there is a special sound called hissing sound. The heat energy evolved. This process is called slaking of lime, and the compound formed is slaked lime, calcium hydroxide. Calcium hydroxide, if it is passed with chlorine gas, it forms bleaching powder, calcium oxychloride. So this is an important reaction of calcium hydroxide. Calcium hydroxide can be used for the preparation of calcium carbonate. When carbon dioxide is bubbled through calcium hydroxide solution, it is called lime water, you will be getting calcium carbonate precipitated, which can be filtered and taken out. So this is how calcium carbonate is prepared. Next compound is plaster of Paris. How is plaster of Paris prepared? We have to take gypsum, CaSO4 2H2O. Gypsum is taken and it is heated at 390 Kelvin. Partially it loses water. Okay, plaster of Paris is CaSO4 half H2O. This is plaster of Paris. So you can see it will lose 1.5 molecules of water. So just to make it whole number, multiply by 2, you will get 3H2O and CaSO4 dot H2O. Instead of half H2O, we multiplied by 2. So you are getting CaSO4 whole twice dot H2O as plaster of Paris. So this is how plaster of Paris is prepared from gypsum.